Hi friends, you're watching tanutechworld. I am Richik Ghosh Thakur, and today we'll be making a very affordable solar lighting system, and which is very reliable first of all, and secondly it's very efficient also. So unlike other solar lighting systems that you find in the market which you can buy, so the problem with the solar lighting system is that they are not reliable and the circuit is not that efficient. So but this solar lighting system, the main advantage is that you can buy this, these are bought out items that we buy from the market, and if one component gets damaged, you can straight away replace that. So there is no actual board that you want to replace. So there's actually several modules. So this is a modular light solar lighting system, and to do this we need some components. As you can see on your screens, we need two DC to DC buck converters and rated at 3 amperes each, and then we need a PN junction diode, preferably 1 in 4007 PN junction diode that will be suitable for this. And next you need heat sink, aluminium heat sink. So you can make this out of an aluminium strip. You can cut the aluminium strip and you can make this. And next we have two LED strips. So these are cob lights. These are also known as cob lights, and they are rated at 1 watt each. You can buy them at your local market. They're available at 13 to 15 rupees, I think. And they have integrated heat sinks within them, but these heat sinks are very poor in performance. So you need to clamp them or attach them to the heat sink, which you can see on the left hand side. Then you need 3 batteries, 18650 cell batteries, rated at 2 ampere hour each, and they work at 3.7 volts nominal. You can charge them up to 4.2 volts. So these we have taken 3 batteries, and we have the total capacity. We'll connect them in parallel, and the total capacity of these batteries will be 6 ampere hours. So on the right hand side we have a BMS. You can see a small chip. So this is the BMS for our batteries. On the right you can see a push button connector. So this push button you need for operating the system. On the right hand side you can see a heat sink or a thermal paste. So this thermal paste is very essential. So you have to apply it on the bottom of the LED and then paste it to the heat sink aluminium strip, and then you can clamp it or screw it, and then or else you can also glue it. It's no problem. And then you need, apart from this, you need 2 3-watt solar panels that also you can buy from the local market. So these are the 2 3-watt panels, and they're at the back side, and you have to make sure that the bypass diode is there in the 3-watt modules. If it's not there, then it's also not a very big issue. So these 3 batteries will connect in parallel, and we have covered them in heat shrink tubing. As you can see, 2 of them we have covered. So this is the BMS, rated at 4.2 volts, so it charges up to 4.2 volts. And these are the 2 cob LEDs rated at 1 watt each, and you need to clamp it to this aluminium heat sink with the thermal paste. And you need this PN junction diode also, which I told. After that this is the your DC-DC buck converter. So we'll open this now, and we'll take this out, and you can see this has 2 inputs and 2 outputs, and we will connect them. We'll show you how to do that. So we'll open the second one. So one will use for charging the batteries, and one will use for operating the load. So these are the 2 DC-DC buck converters for this purpose. So next what we'll do is, yes, we need to connect the push button also. So these are the components. So now firstly what we'll do is, please follow the circuit diagram, and what we'll do is, after connecting, make sure that the bypass diode is connected. Now we'll connect our 2 wires, red and positive and negative, red and black wires, which represent positive and negative side. So these 2 from each of so these 2 panels need to be connected parallelly. So not in series but in parallel. So the positive will go into the positive of the other panel, and the negative will go to the negative of the another panel. and another connection from any of the panels you can take, that also parallelly, and that you can take as your main output from the solar panels. So here we will solder this. I will make sure it's properly soldered, and then after soldering we'll put in the cap and we'll put in the protection. So this will make sure it's okay. So this is the two output terminals. So now the connection is made. As you can see, these are two 3-watt panels. The connection has been made. Now we have marked the batteries positive and negative side. So batteries we need to connect it in parallel, and for that we need to connect all the positive sides and all negative sides, and all the positive sides in one terminal, all the negative sides in another terminal. So this will make the battery parallel. And first what we'll do is we'll cover the battery with this paper tape so that the battery stays in place. So what we are doing is we are making a battery bank rated at nominal 3.7 volts and having capacity of 6 Ah or 6 ampere hours. So we have stripped this wire in two sections so that this can be easily soldered to the batteries, and we are applying flux now to the battery terminal so that soldering can be done very easily. So before soldering we need to keep in mind that we need to scrape off, or using sandpaper we need to scrape off the terminals. So this is required because unless you do that the solder won't catch. So the solder will not adhere to the surface. So this is essential. So this again a negative side, you're going to do that. As you're seeing, we'll do the negative side and we'll connect all the terminals in the negative side. All the three sections will connect, and you can select wires based on, you can either select 1 square millimeter will do. We have selected lesser value, but you can select wire up to 1 square millimeter, so that will be good for this project. So after soldering you need to check whether it's properly soldered or not. After that you see this is the BMS. These are the two battery terminals, as you can see in the top and bottom sections, B minus and B plus, and we need to connect it to the B minus and B plus terminals of this battery. So what we are going to do is we are going to solder this, and in the middle you can see the power out, P plus and P minus. So first what we will do is we will solder the B plus and B minus terminals. So this is easy. So you can either scrape off some parts of the terminal. That will make your work easy, and rest of the soldering will follow. So negative and positive side of the battery we have soldered, and then we need to solder the power out of the battery also. So the power out of the battery will as you can see, it's coming out from the BMS. And what the BMS does is it prevents the batteries to be overcharged, and this also prevents deep discharge of the batteries. So this is another good aspect of the BMS. So here we are not using the BMS for to prevent overcharging, because we are using a DC-DC buck converter. So what we are primarily using the BMS for is we are using it for preventing deep discharge. So now we have connected the BMS. As you can see, the BMS has been connected, and now as you can see, these two bottom terminals will be used for charging, and the power out from the BMS, that will be used for discharging the battery and running the load. So we fix the BMS using this paper tape and insulated as far as possible. It is not a problem if you insulate it entirely, so you can do that. Next is we'll connect terminals, we'll connect wires to the terminals, the input and output terminals of the DC-DC buck converter. So we will solder, we are soldering and connecting. Be sure to apply the solder evenly and properly, so that it does not fall off in the future. This needs to be permanent. So next what we do is, first we are preparing our charging circuit. So what we do is, we soldered a diode. So we have soldered a diode to prevent backward current. This is very important, and we'll solder it to one of the terminals. So this will do, and we'll apply a small heat shrink tube, and we'll heat that heat shrink tube so that the diode stays in place, and that is also insulated. So after that we solder the negative terminal. Now what we have done is, we have soldered the DC-DC converter for the charging circuit. Now what to do is, we'll connect the push button. We have connected the push button. Now it's time for connecting another this DC-DC buck converter. Later on we'll calibrate it so that the voltage is constant. We'll set the voltage later. We'll now connect it. This is the discharging port, which will be via the BMS. So the BMS out will go to the switch and then to the output DC-DC converter. So now what we do is, we now will connect the LEDs. So both the LEDs again will be parallel. So the output voltage will be 3 volts. So as this LED is rated at 3 volts, and as it is parallelly connected, so we'll connect positive part to the positive part of another LED and negative to the negative. This will be parallel. So the overall rated voltage will be, of course, 3 volts, and the power output will be about 2 watts. Now that we have connected the LEDs, so it's what we'll do now is, we'll just calibrate this DC-DC buck converter and see if it's working or not. Okay, so now we can connect the LEDs. We will solder the LEDs into place. So LEDs will be soldered, of course, in the out plus and out minus output ports. Input ports will be from the BMS. And as you can see, after the push button is pressed, the LED lights up pretty good. The LEDs are rated at 3 volts, so make sure that the DC-DC converters are set at 3 volts output. You can also set it at 2.9 volts, that will not be an issue. And now what we are doing is, we are setting up the charging port. So this is the solar charging port. So in these two ports we connect the positive and negative parts of the solar panel. So here we are connecting the positive and negative parts, terminals, wires. So we are connecting that. So this port is very good for connecting, and you can open it anytime. This is very flexible. Now we'll test the circuit once. So it's working. Charging is also working, discharging is also working, buck converters are performing good. Now we'll apply heat shrink paste to the LEDs back side, and now we'll paste them to this enclosure that we have made. So this enclosure is very simple. So we have just purchased this enclosure. You can find it in the market. Any enclosure will do, frankly. And then you can fix, or you can paste the heat sink strip, and then after applying the thermal paste to the LEDs, you can glue them. So that also works, guys. So you can glue them. So what we have done is, we have glued them, and now we are just we are fixing the different push buttons and ports. The solar port we have fixed, and now we are fixing the push button. So this will be on the top of the enclosure, so it's easy to access and easy to operate. And now we'll see that everything is in place, everything is fixed properly, positive and negative are marked, the solar panel input and output. So from the back side we'll make the connections which are necessary. So LED, which is the load, so we'll just connect this load to the DC-DC converter. So now you can see we have connected the LED load, the output DC-DC converter. So now what we are doing is we are connecting the push button to the buck converter, which is in series with the output of the BMS, and now we'll place the entire circuit in the enclosure. This is the connection for the solar panel. Now you can either screw this entire thing, or you can just apply instant glue and you can fix this. And now what we are doing is we are applying double-sided tape to fix this, like we are doing it in we are doing to fix this DC-DC buck converter, and same thing we are doing to fix the battery. So this is not like temporary. Do not think this as a temporary feature, but this is also permanent, so you can make it more permanent if you want. You can add instant adhesive if you want, you can add M-seal, you can fix it to M-seal if you want also. So now what we are doing is we are fixing lugs and some heat shrink for insulation to the output of the solar panel, so that we can fix it easily to the input terminals of the solar input to the system. So this is the solar terminal. So we are fixing the two solar wires, positive and negative, to the entire system. So now you can see the system is ready, and this is performing good. So now we have also conducted the charging test also. So charging test also works good, and you can see the system is ready. System is very portable, it's lightweight, it's modular. You can buy all the parts. If one part is non-functional, you can replace them. So here is the entire thing. Again, you can see the circuit diagram. It's in the description also. You can download the circuit diagram and you can try it out for yourselves, and make sure to comment what if you have done, if you have made this, how was your device. You can comment. You can also comment how was the device, and any suggestions you would like to give us, you can do that. And make sure to like and subscribe and share this video, please. Thank you.